All right, so I am recording right now. So I will share a few some news first. Okay, it's factual. Meta has officially started to lay off people. Can anyone guess how many people they laid off? Hmm? Go ahead. Give me a number.
Not half, like more like 30%.
Well, I don't think it's 30%, but it's 3,000 something. Is it 25%? 3,000 something.
Yeah, I was about to say 1,000. I
Oh,
forget the
okay.
number, but
And some of those people who got fired also said that they got a good review before, like immediately before they got fired, like the previous review cycle, they got a favorable review. So I'm not sure exactly what is going on, okay, but this is just what I read this morning. Um, So that's I think that is important, okay, because I think they're not just letting go of HR people. I think some of those people are developers or they're software engineers, and some of those have even good reviews. So what is going on, right?
yeah, I
Why
always
are
wonder
they?
why do people get laid off like that, even if it's good.
So that's a good
Because
question.
like my friends always told me, if you're good at your job and you're good at what you do, like you shouldn't worry like too much about the money, like it's gonna be done to you and stuff. That's fair. But when
Mm-hmm.
I hear about stories like this, I'm like, these people to get into metal, you have to be like at least like competent, and
Mm-hmm.
even then, they still get laid off. So I always wondered what's that about.
Well, I have some theories about this, yeah, and I talked to some really smart people about this too. So Meta is interesting in the sense that the software engineers, they're not exactly always writing software. A
Yeah.
lot of times they are actually trying to perfect the social media platform. So they are actually they're more like salespeople.
Yeah.
They're more like doing marketing instead of actual technical work. So I think the AI took over some of those responsibilities. That's what I think. Okay, so I think the AI has gotten to a level where the AI instead of people can push certain things to maintain, so that people are stuck, right? They're stuck with Facebook. They don't want to leave Facebook because of all the suggestions, friend suggestions, and also the content that they're pushed to. But I think the AI is doing a pretty good job, and that's why they don't need people anymore.
Yeah.
Okay, so that's the first bit of news, and then the second one is the homework assignment. So I'm gonna go uh, take a look at the homework assignment, and I'll give you guys a solution, okay, which is not the only solution, but a solution. So there's the conditional statement assignment. And it is important to read the description here and also read the trace that I have for conditional statements, just so that you make sure that whatever you turn in is in the correct format. Yep. So we're gonna go take a look at this. Okay. The algorithm is already provided. Okay. So this is the algorithm in back to the example section. So we're gonna open that up just so that we can see what the algorithm is. That's the algorithm, and this is the flow chart corresponding to the algorithm. Okay. So I'm gonna let it stay at this spot, and then we'll go ahead and use Google Drive so that I can work on a solution that you guys can also download or take a look at if you want to. So let me go to my drive, CISP 300, into the shared folder. So this is where I stash all the files that you can also take a look at. And I believe these are shared correctly, but let me just double check first. Yeah, so they're shared to the public, and I believe the link is correct, but all right, so we're gonna go create a new Google Sheets. And I'll name the Google Sheet with today's date so it's easier for you guys to find it. So today is 2025 02, I think it's 12. Yep. Okay, there we go. All right. And it helps so that if I can actually look at the algorithm at the same time. So I am going to do this trick, and I know most of you know how to do this kind of stuff already, which is just to take a snapshot of a certain portion of the screen and open it up, and then so you can display it all the time. Now, in my case, because this particular projector has a limited resolution, not only because of the physical limitation, but also from your perspective. If this screen has super high resolution, it's still not going to be useful because you guys are too far away from it. All right, so now I can go back to my spreadsheet and actually work out the three examples. So the first thing is I need an example where W is the maximum, so line 2 executes. I need one example where X is the maximum, where line 4 executes. And I also need one example where line 6 executes because Y is the maximum of the three. So with only those requirements, okay, so I'm going to label the sheets. You don't have to label it as such, okay, but I'm labeling the sheet here just so that the name of the sheet reflects what we are working on. So this one is W, and then the next one is X, and then the next one is Y. So this way it reminds me, what each sheet is about. Now, do you have to do it exactly the same way? No, if I read your trace, I can probably figure out which one it is. So we'll work on W first. Okay, we want line 2 to execute. The only way line 2 executes is the condition of line 1 is true. So the only way, well, there are many ways for line 1 to be true. You can have all three values being exactly the same. You can have W to be actually greater than or equal to both X and Y. You can also have W to be equal to one and just greater than the other one. So there are quite a few ways to do this. Okay, and as long as you're not just copying from my example, in the module, you're fine. Okay, so I'm going to start with just the general format. You need line number as a column. You need the value of W, X, Y, and also Z in this case as its own column. And you also need a column for comments, okay? Because you need to tell me what you do after you evaluate a condition. And if you don't like the spacing the way it is right now, you can always kind of adjust it. I'm not going to take any points off if people just use the default width of the columns, but it's just nicer to kind of change it a little bit so that the formatting is just about right. Okay. So if you do something like this, you can actually copy from one sheet to another sheet here. So if I have the sheet already created in Google Sheets, I can just go to the other one. Oh, I forgot to do one thing. I forgot to say copy, and then go here and paste, and then go here and also paste. So it copies all the formatting as well as the entire column, including the formatting. So that's kind of nice, so I don't have to go through the formatting again. All right. So when we get to a particular trace, we always start with a pre, which means I need to know what is given to me. What are the assumptions? So according to the algorithm, we have to make assumptions about the values of W, X, and Y, but Z is unknown. Okay. So in order for X to be the maximum, okay, can I help you guys with something? All right. Do we have a sorry? You cannot sign in?
I think his account has been blocked.
Hmm. All right. Well, I cannot address it right now. So we'll try to address that after class. Yep. All right. So let's focus on the content right now, and then we'll try to get everything squared away after class. All right. So W can be okay 4, X can be 3, and Y can be 4 again. Okay, that will still make W the maximum. Somebody's going to say, but in this case, isn't Y also a maximum because they are both 4 and 4 is the largest values of the three? The answer is yes. Y is also the maximum, but the logic does not go to line 6. Okay, so this will work. Okay, so now we look at this and go like, okay, what is the next step? Well, the next step is always to evaluate whatever is on line 1. So line 1 doesn't change anything. So there's nothing to specify here because nothing is being changed. But you do have to tell me what is the condition of W is greater than or equal to X and W is greater than or equal to Y. So you have to tell me that. Um, it can be as simple as the condition is true. Although I would much rather you guys to say, what condition we are talking about. So we can say, w is greater than or equal to x, and w is greater than or equal to y is true. Okay, because it's important to note that the condition is true because this is the reason why we end up on line 2. Okay, so that's why it is important to state in the comments what is the condition. So you go to line 2. Line 2 is going to use w, which has a value of 4, to update z. So z ends up with the value of w, which is 4. And because that ends the then statement of line 1, so after that, there's nothing else to do. We just get to post. So do we have any questions about the trades where W is the maximum, or one of the examples where it works out this way? Okay, no questions? All
I
right.
did differently, but I understand what you're trying to say. How you fix it.
Yeah, okay.
There's different numbers.
Different, yeah, you can use different numbers as long as it makes
Yeah,
sense and works
as
out.
long
It's,
as W ends up being a mouse.
yeah,
Yeah.
exactly. Okay, so that works. Okay, so now we move on to x, and we also start with a precondition in this case, but this time I need line 4 to execute. So this gets a little bit more complicated. In other words, how do we make sure that line 4 is the one that executes? Because out of line 2, 4, and 6, one and only one of those will execute according to this logic here. So one thing that can help you is to go back to the flowchart. Now, I personally do not like to use flowcharts, but in this case, if you think the flowchart is going to help you, hey, use it. So now we go to the corresponding line. So line 4 is corresponding to z gets x. Okay. So now the question is, can you backtrack how we got here? Well, yes, we can. Because we got here because x is greater than or equal to w and x is greater than or equal to y is true. But in order to get here, we also have to make sure that w is greater than or equal to x and w is greater than or equal to y is false. So you have to make sure that those conditions are met. Okay. So w is not greater than or equal to both x and y, and we also have to make sure that x is greater than or equal to both x and y. So now we go back to the spreadsheet, and there are a few easy ways to do this. One really obvious one is just to make x, truly the maximum, right? And then you just go like, okay, we'll make the other two like not as big, and then z is unknown. Okay, so now we go to line 1, and the comments on line 1 is that condition is false. So you can start with x is greater than or equal to x, and w is greater than or equal to y is false. The bottom line is you have to tell me the condition of line 1 is false. Then the next line, where do we go? Come on, tell me. What is the next line number? Yes. So what line is it on? Line 3, that is correct. Okay, so we move on to line 3 here. We do not go straight to line 4. We have to get through line 3 before we get to line 4. So on line 3, you have to tell me that w is greater than or equal to w, and wx is greater than or equal to y is true. And that would be the reason why we get to line 4, where we take the value of x as the right hand side, update z, which is on the left hand side of the assignment, and now z ends up with a value of 6. And after that, we are done. So are we good with this one?
Yeah.
Okay. So if you have some formatting thing that is different, but you still indicate that you know how to evaluate the conditions in this particular order, I'll still give you points. Okay. So that's the important part is you have to tell me the flow of the program and not just go like, oh, we're going straight to line 4 and we're done. Yes. You can fill them in, in the post. I just typically just leave it blank. Because the whole idea of the word post is to mean is to indicate to myself I'm done here. Yep. Because this algorithm is not too complicated, so it is you can do it in one shot, And then later on in the semester, we'll have something that's complicated where I might work on half of it, and then I go to the bathroom, make some coffee, and then I come back. If I don't see post, that means I'm not done yet. Okay, I have to continue to work on it. But if I get to post, I can come back from the bathroom break and I look at the whole spreadsheet and go like, oh, I was done already. Okay, I can move on to my next homework assignment. So yes, so if you want to copy all the values down here on the post row, that's fine. I'm not going to take any points off. All right, so the last one is y. Okay, when we use line 6. So once again, we have a pre, and then we just have to give assume w x y have certain values where y is the maximum, and this one you don't really have an option. Y actually has to be greater than both x and y. So excuse me, y has to be greater than w and x. Okay, but w and x can have exactly the same value, so that's no problem here. Z is unknown to begin with. On line 1, I mean, I'm just going to be super lazy now. Okay, I'm just going to copy both of these, and then we'll modify a little bit when after we paste it here. So this is false. Okay, fine. We get to line 3. This condition is false as well. And then we get to um, we go straight to line 6 in this case. Okay, because when the condition is false with a conditional statement, we go to the else statement, and on line 6, that's the else statement corresponding to the conditional statement that starts on line 3. So we go straight to line 6, which ends up using the value of y, which is 6, to update z. So z now ends up with a value of 6, and we are done. Is that okay?
Yeah.
All right. Yep. I won't take any points off if you say line 5.
Yeah,
Okay. So from here on, those, line 5 does not need to be in the trace, because the word else serves only one purpose, which is to separate what we need to do for the then versus okay, let me put it in a different way. It separates what we need to do when the condition is true versus what we need to do when the condition is false. But the word else by itself there's nothing to do with that word. So tracing it is fine. Okay, there's no problem. It's just that it's not necessary. All right. So are we doing okay so far? Okay. So this is just one way, for the whole thing to set up. It's not the only way, okay, obviously. So you guys can have entirely different values here, as long as whatever value you choose is consistent with these two conditions being false for this particular spreadsheet. It's okay, not a problem. And you can have additional rows, not a problem either. All right. Mm, okay. So now we are done with this. Okay, so now it is on the share drive. You have access to it now, and if you want to review the answer, you can certainly go there to review the answer. So now we go back to loops. Okay, because we are not quite done with loops. We're almost done with it, but not quite. So we go back to the loop module. And I believe we are down to the example. I think we talked about this already, okay, because I kind of commented on how ugly this thing is. There's actually a way for me to make it look nicer, to be more conventional. Um, do you guys want me to make it look more conventional, or is this okay? This is fine, okay? All right, cool. And I believe that we also looked at the BNF of both the do loop and also the while loop on Monday. Yes, I hope so. Okay, very good. So now what we do is we're going to look at an example. So this is the code that I'm going to trace. So I am going to use the same standard of tracing a program as what I would expect you guys to do with the homework assignment. Okay. So there's a new homework assignment. I'll describe it in just a little bit. But first, I'm going to show you the trace that I have for this particular algorithm. So the algorithm starts with line one. It assigns a value of zero to x, so x becomes zero. And then the next line is the beginning of a while loop. It says, basically, as long as x is less than 3, do the following. The following, which is the body of the loop, is consisting of line 3, basically, which is just adding 1 to x, is incrementing x. So the trace, okay, let me get rid of this one here. And then I'll do the same trick so that we can look at the algorithm as I scroll through the trace itself. So let's do this, make it always on top. There we go. All right, so the algorithm is here and the trace is right here. So the precondition is I don't even know anything about x. There's no need to make any assumption about x because the first line is going to give it a value. So that's why x has an unknown value. And the comment is it doesn't need to be here, but I just want to explain that we were not told about any assumption about the value of x. After line one executes, x ends up with a value of 0. Okay. On line 2, it has a condition to evaluate, which is x is less than 3. Now, because x is not changed on line 2, it still has a value of 0. So the condition becomes, is 0. 0 is less than 3 is true. And as a result of that true, we go to line 3, which then increments the value of x by 1, and then we go back to line 2. So the transition from line 3 to line 2 is the important transition here because this is how a loop executes. Okay, you go back to an earlier line, and in this case, you go back to an earlier line or a line that is before to try to make a decision. Is it time for me to exit the loop, or should I go for another iteration? So in this case, we have to go for another iteration because this is still true. Because now x has a value of 1. Let me unselect so it's easy to read. So when we get to line 2, we look at this cell here and go like, okay, what is the current value of x? It is blank. So when it is blank, then you look up until you find the last update, and the last update was a 1. So that means x currently has a value of 1. So the question is really asking, is it true or false that 1 is less than 3? Well, the answer is true. And when the answer is true, then we go for the body of the loop again, which is on line 3. So now x is incremented to 2, and then we automatically go back to ask the question again. This time the value of x is 2, but 2 is less than 3 is still true. So we go to line 3 again. X increments one more time from 2 to 3, and then we go back to line 2. And on line 2 this time, because x has a value of 3, so now we are evaluating, is it true or false that 3 is less than 3? And the answer is no, 3 is not less than 3. And as a result, we exit from the loop, and then we get to post. Do we have any questions about this particular trace?
The trace, no, but I know we're like already deep into this, but ask again, like tracing, right? Is this basically for us to explain what the code is doing, right?
Yes.
Okay, and also documenting, like,
Yep.
okay, that's
Yep.
fine. So I understand what this is.
Yep. Mm-hmm. So that's basically what we're going to be doing for the entire semester. Okay. And you guys go like, this is so boring. Well, trust me, things will not stay boring for too long. Okay. It will get kind of interesting. Oh, it will get pretty complicated.
Yeah, but it's good to start.
It is good to start because the way I teach this class is I front load a lot of the other classes to this moment, to the first class. So when you take CISP 360, which I don't teach, okay, most, actually, I take it back. All of the concepts that you learned in this class is going to be reusable in that class. Okay. In fact, I hope that you'll be slightly ahead of the rest of the class because the other classes do not talk about C++ syntax. They talk about Python syntax. So they have to relearn, they have to unlearn Python and then relearn C++ for your other classmates in CISP 360. You don't have to do that. This is straight up C++ syntax already. Now, is it the full syntax of C++? No, I'm introducing like little bit at a time, okay? Because I don't want to overwhelm you guys with the full syntax of C++, which is actually really complicated. But you are already learning actual C++ syntax already. But when you move on to Cisp 310, which is Assembly Language Programming and Computer Architecture, the way I describe how things work in this class is completely relevant to Cisp 310, especially if you take it from me on this campus. So you're basically pre-learning some of the concepts that are crucial to some of the other classes that you have to take along the way, instead of learning something and then you have to unlearn something and relearn something because it's a little bit different. So that's the way I teach this class. All right. So are we good with this one? So when you're studying, another thing you can also do, I did not actually quite make the flow chart of this one, but you can. So draw a flow chart for the algorithm and display it side by side. So you would have the text version of the program in C++, a flow chart, and also the trace all presented at the same time. So that will help you understand how to relate between the text, which is the syntax, the flowchart, which is the meaning of the syntax of the actual code, and what happens when the code executes, which is the trace. So those three pieces can help you when they're on the same screen. I think that can really help you understand what is going on when you are handling a loop. Yes, go ahead. The bracket. The,
So we include a line bracket.
the bracket does not have any meaning. That's why it's not traced. You mean line 4? Yeah, line 4 is the closed brace, not a bracket. So a bracket is a square looking thing. Yeah, so when you say parentheses, this is the parenthesis. When you say bracket, this is a bracket. When you say brace, that's a brace. Yeah, just to kind of differentiate between the three. But the answer to your question is line 4 has no particular meaning. So not when the program is running. Now, it has a meaning when you look at the syntax. It's kind of like a punctuation. So when I'm talking, I don't say, this is the end of a sentence, period. Capitalize, first letter. This is the next sentence, right? I don't say anything like that. It's kind of like that. It's a punctuation, but by itself, it's just like here, so that we know that, oh, okay, that's the end of the body of the loop. But otherwise, there's nothing for it to do. All right, cool. All right. Any other questions related to this trace? Yes.
Line one, how we know X is not changing because it's equal to zero. We know X is not changing.
On line 1, x becomes 0 from whatever it was before. So, but we did not make any assumption. When I presented this problem, I did not say assume x starts with the value of blah. I did not say anything like that. So, without any assumption that is actually stated, then the precondition has to make an assumption that we don't know anything about x, and therefore the precondition has a question mark to emphasize that x starts with an unknown value. Okay, and there was a question back there. Yes, go ahead.
Like the condition like while specifies like that an action should be repeated, right?
So one way to look at the word while is to equate it to as long as. Basically, it specifies the condition in which we perform another iteration of the loop.
So in the situation x, as long as x is less than 3.
Correct. Yep. Go ahead.
I think you're just missing something. Like you're opening, just missing.
Well, for anything related to the homework assignment, let's do it after the class. Okay, so this is class time, and we're gonna do everything that is related to the whole class. So if it is only something related to you, we'll deal with it either before class, in my office hour, or after class. I do have office hour from 8 to 9. Okay, so if you have anything that you need to talk to me before the class, you're more than welcome to my office, during the office hour. But usually after this class and before my next class, which starts at 10:30, I'm usually available as well. So that's also a time for you guys to talk to me, kind of individually on things that only affect you. Are we good so far with loops? Okay. All right. Question? No. Okay. I just thought that you had a question because okay, that's okay. Sometimes I misinterpret. Okay. And that's your conditional statement. Let me close that one too. Final exam schedule. That's actually kind of important. All right, so since I'm here already, I might as well talk about it a little bit. So for the people who want to know when is our final exam, I only go by the college schedule of when final exams occur. So now that we are at the spring 2025 final exam schedule. Which one should I look up? There are four options here. So we have to make decisions, right? Is this class a daytime class or is this a evening class? It's a daytime class. Okay, very good. Do you think any one of these apply to us? Is this class being conducted as a math learning center thing?
I don't think so.
No. Okay, very good. Is this an integrated ESL course in any way? Nope. Okay, so I think it's pretty clear that only the first one applies. Okay, so we click that. And now, it says, exam schedule for classes that regularly meet in the daytime. The first column says day classes beginning. In other words, when does this class begin? This class begins at 9 o'clock, and it's a Monday, Wednesday class. So that means this particular role applies to us. The class starts between 8:15 and 9:25 a.m. The class meets on Mondays, Wednesday. We don't meet on Friday, but some other classes do. So your final exam date is going to be May 19th from 8 to 10 a.m. Okay. You might want to jot it down or put it on your calendar, okay, just to make sure, okay, because I will mention this again close to the end of the semester, but it doesn't hurt to put it on your calendar like right now so that you know that, oh, on that particular day I have to get to school earlier than usual, okay. It is not starting at 9, it is starting at 8 a.m., 1 hour earlier than our usual lecture time. Okay, so it's a little bit different from your routine. Anything that is different from your routine, you probably want to put it on your calendar because it is not very usual that we can remember things like that, exception to the rule. Question.
Are we gonna have like smaller tests, or is it gonna be one big final?
All right, so that is covered in the syllabus.
I read the syllabus. I'll read it. I'll read
I
it.
did not hear that.
Okay.
La 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 la. So make sure you guys read the syllabus because it is assumed that you have read it and you know the expectation already. Okay, so it's really important that you know what I am expecting so that there's no confusion. It's like, but I didn't know that you do not accept late assignments. Well, it's in the syllabus. Okay, the syllabus has been available since before day one of this class, so it is important to read it. Is that okay? All right. And attendance is important too. Okay. All right. Any other questions at this point? Okay. If there are no questions, I am going to move on to the new homework assignment. Okay. So this is me grading stuff. Okay. Get rid of all that stuff. So your new homework assignment is called the loop assignment. It is due in a week. So next Wednesday, the due date is at 9 a.m. right before the class because I don't want people to be doing the homework assignment last minute and skip the class as a result. So that's why the due date is right at the beginning of the class. Okay. I don't want people to be that shaving that close to the deadline. Typically, when you get a homework assignment, try to get it done or at least get started on it within a day or two. Okay, and not just kind of wait until the last day to do it. Okay. When I was a college student at San Francisco State University, I would be taking like a class of compiler. These are upper division classes, and most homework assignments or projects, have a due date of about 2 weeks. Okay, so from the time the assignment was published to the time where I have to turn it in is about 2 weeks. Can anyone guess usually how when I get the homework assignment done?
A week before?
Okay,
No,
a week
5 days
before,
before it's due.
5 days,
3 days. Could you
hmm?
3 days ago?
2 days before the due date? Nope, it is within 2 days after the homework assignment is published. So I would get it done within the 2 days and have 12 days of nothing to do.
That's good for you.
The teaching assistant, the TA of the class, would typically be behind me. So after the first two homework assignments, the TA decided, oh, I don't have to create the solution of the homework assignment anymore because tech usually get it done within the 2 days before the TA get a chance to do the homework. But why do you think that is the case? Okay, if you look up my personality, okay, INTP, I'm one of those people who are perpetually either late or just in time. But when it comes to homework assignments, I get it done within 2 days. Why do you think that is the case?
Because you know yourself, like if you do it like any later,
Mm-hmm.
you're gonna do it like at the time, like cutting it really short, and you don't want to do that. You know yourself, so you
I
prepare.
know myself, okay, that is true. But for a lot of things, I still push it all the way to the end. Okay, like my tax stuff. I look at the date and go like, what is the last day I have to turn it in, and I usually just kind of really, really wait until the end. Okay, go ahead.
And you can make free time for your personal study to study something
To
else.
study something else. Okay, well, partially true. Okay, I would say that's not a bad explanation. Yes, peace of mind. Well, I'm one of those people who can really do things like last minute and not really feel the pressure. When other people are walking, running around with their pants on fire, mine can be on fire, but I'll look like cool as a cucumber. Okay, I'm just one of those people. No, the only reason why I got things done in 2 days is because I like it. I'm actually interested in the homework assignment. Okay, so I think that is important. Okay, if you're entering and getting into this particular field, okay, which is software engineering or computer science, however you want to call it. Okay, some of you want to become a data scientist, some of you want to become a data modeler. Okay, there are many job titles that are related. Doesn't matter. If you're really into it, like this is actually your interest, this is what you want to do, that's great. Okay, and this class is really here to help you figure that out. Okay, is this something that you enjoy doing? Is this something that interests you? Where you go like, I want to know what the professor's going to give us next time. Okay, what homework assignment are we going to work on? So if you're excited about that sort of thing, that's great. Okay, um, I think it is important. I just think having an interest in what you're doing is more important than an actual talent of doing it. Because if you like doing something, you'll be spending time doing it and not notice the passage of time. All right. So this is your homework assignment. I give you a slightly more complicated algorithm. So you can see that there are two variables involved here. There's x, there's y. And the loop is set up a little bit differently. Instead of asking whether x is less than something, I'm asking whether x is greater than 0. But otherwise, it's kind of the same thing. Okay. So I need you to follow all the conventions that we have talked about today when I traced my loop, pre, post, line number, column, and one column for each variable, blah, 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 blah. Read the instructions. Okay, and how you want to turn it in, I give you a lot of options. You can use a spreadsheet to record your answer or record the trace. For those of you who want to punish yourself and decide not to use a spreadsheet, go ahead, knock yourself out and use some other way to make a table. As long as I can read the table, it's good. Okay, but I think a spreadsheet is really the easiest way to do it. Okay, you're not using the complicated formulae of a spreadsheet. You're just using a spreadsheet like a table. Okay, so I think that really is the easiest way to do it. But if you are using a cloud-based spreadsheet such as Google Sheets, then you have to share it with this particular email address, and I need to have edit access to the file, not just view only. Okay, so make sure that happens. On the other hand, if you have, let's say Excel already installed on your computer, and you like to use Excel because you don't need internet access while you're doing it, that's fine too. Okay, in that case, upload the file to the assignment interface. So I can do both. Okay, either way is fine. Is it clear enough what you need to do for this particular homework assignment?
I have two questions.
Go ahead.
Uh, so for the algorithm, right? Are we only gonna use x is equal to 5 and y is equal to 2, or after like, or can we like? Guess what I'm saying is that this looks like it's gonna repeat, and it's not gonna, and because 5 is always gonna be greater than 0, right? Wait, okay, I think I see what. I just saw the y.
All right, so let me do a quick analysis here. Okay,
Yeah.
so x starts with the value of 5. So the question is 5 greater than 0? The answer is yes.
Yes.
So we know that we are not going to skip a single iteration. We are not skipping the entire loop at all. Second thing, in the loop, what do we do to x? X gets x minus 1, which means x gets smaller for each iteration. So 5 becomes 4, 4 becomes 3, and so on. So eventually, it's not going to be greater than 0 anymore. So the loop will exit
Yeah,
in this
I
case.
just didn't look at it.
Okay. Yep.
Another question. So the y, right?
Mm-hmm.
So y is gonna get.
Y is initialized with a value of 2, and then for each iteration, I'm adding y with the value of x, and then that becomes the new value of y. So once again, with any assignment operation, what you need to do is to find out the value of y and the value of x at the time when that line executes, and then you figure out the sum. Okay, what is the sum between those two, and then use that sum to update y again. All right. Okay. Okay. Do we have any questions back there? No, I'm talking about you two. Yes, you actually. Okay. Okay, so you can, if you have a question that the class may be interested in, just raise your hand, and and I can help address that, because when you guys are talking, other people can hear you, and then you're distracting the other people. Okay, all right, go ahead.
They were having trouble with this stuff,
Mm-hmm.
with this line, because you probably understand it much better than I can to explain it easier.
Okay.
They have it written out currently.
Okay, so I can only address this after the class. Yep, because that's a very individual kind of thing. Yep. All righty. So now we continue with new stuff. Okay, so we are done with loops. We're done with compound or block statements. So now we are moving on to the next topic, which is nested control structure. And I kind of messed up here, forgot to release it. I got it done already, but then I forgot to release it. Did I make it to an announcement? Nope, I did not. Okay. That's my fault because I got it done actually like day before yesterday. So now we're going to move on to nested control structure, which means you have one control structure nested inside another one. This is the module. Okay, so it starts with a very simple example. Okay, while x is less than 5, x gets x plus 1. So we kind of know this is one that's pretty simple. And I'm not going to go over this one, okay, because we just worked out one that looked like this. Okay, the only difference is we have a different number here. This one goes through 2 more iterations compared to the one that we just talked about. So now we look at a more complex example. So let's start with this one. Okay, so when you look at this particular algorithm, what is the first thing that you need to do when you look at an algorithm? Something like this. Okay, so if I were to ask you how many loops do we have here, what is the answer?
Let's see. Oh wait.
There are 2 loops, yes. And how are those 2 loops related to each other? Mm, well, one depends on x, to specify when we stay in the loop. The other one depends on y to stay in the loop. And one would update y, change it to a 0, and then update x at the end here. The other one will update y and then update the variable s here. Okay. What else? What else do you get when you read the algorithm like this? What about the indentation? What is indentation?
You're an estimate inside of indentation. I don't know the exact definition from your size, but from what I experienced, like if from what I've seen, so you're putting inside like an action, like an if, a while, like
Okay.
basically, and then
It's related to what you said, but indentation is really just the number of white spaces from the beginning of the line to the first character of that line. That's indentation. So in this case, you can see that there are levels of indentation, right? So the initialization of the variables s and x has no indentation. It is right at the edge of a line on the left hand side. So it's this close brace here. But the while is also at the same level, but everything from line 4 all the way to line 9, they're indented by one level, right? And then everything from line 6 to line 7 is indented even one more level. Indentation in this case is here to tell you about how things are nested. In other words, if you have a folder inside a folder, that has indentation, okay, when you display it on the screen. Okay, I'm sure you guys know how to navigate in the folder structure inside Windows to find something in a folder inside another folder inside another folder, right? So you can, when you look at the tree structure, or when you look at the organization of the folders, it also uses indentation to tell you, oh, this folder is a subfolder of this folder is a subfolder of this one, and so on. So indentation serves about the same purpose, except in C++, indentation is only for your eyes. Okay, it's only for the person, the human, who's creating the code. The compiler does not care about indentation. In fact, I can write this entire program on one line, and the compiler goes like, "Sure, no problem. I can understand it."
they just
It's just for us to make it easier for us to understand what is inside of what else. Okay. So when you read an algorithm like this, and we are going to be reading, or looking at algorithms that are increasingly complex, okay, where there are multiple levels of indentation. So the first thing you need to understand is what is the structure of this particular algorithm. So in this case, I still use a kind of flowchart here to show you the structure of the entire thing. So let me do the same trick that I did earlier. Get rid of this thing here, and then we just make a photocopy of this one, and so that I can show you uh, the code and also the flowchart at the same time. So, and then stash this one over here, and now I can scroll down, and I'm gonna have to zoom out in this window a little bit just so that it can show more of the algorithm itself. So now we have the starting point of the entire algorithm, which matches basically whatever is before line 1, precondition, so to speak. So now we have s equals to 0 being line 1 right here. And then after that, in a sequence, is x gets 0, which is here. And then we have the loop. The outer loop is here. So from line 3 all the way to line 10 is the outer loop. And the outer loop is going from here. And then the inner loop is in yellow. Exactly. Mm-hmm. So the inner loop is the one in yellow, but y equals to 0 is one of the steps of the outer loop, because y equals to 0 is inside the curly brace or the brace on line 3. So that makes y equal to 0 the first statement of the outer loop. So what do you think is the second statement of the outer loop? Can someone describe where is the second statement of the outer loop? Yes. Line 7. Nope.
line 9.
Nope. Well, okay, one hint. It is not a single line. The second statement of the outer loop, which is the statement after y equals to 0, is not a single line. It's not specified on a single line. It's broken up into multiple lines. So the question is, what is the range of lines? Okay, that's still a single line. What is the range of line numbers? It is from line 5 to line 8. That is correct. Yeah, so from line 5 to line 8. Okay, so let me highlight it. Oh, I cannot highlight this one. So from line 5, which is where the word while is on, all the way to the close brace on line 8, not 9, line 8. Okay, so 5 to 8 is the second statement of the outer loop. You go like, but wait, that's a whole loop. Yes, but a loop is a statement. Okay, one entire loop can be seen as one statement. Okay, and if anyone is thinking, but Ted, you never talked about this. Yes, we did on Monday. Okay, so where is it located? Okay, because it is important for me to point out where you find the information. I am not implying that you guys are not studying. I'm not implying that you guys are not reading ahead. But whatever it is, okay, you need to know how to read the content. And I don't know how that popped up here, so I'm gonna close that. All right. So we'll go back to loops, okay? The discussion of loops, which is right here, and open it in a new tab so I don't have to kind of switch between a bunch of stuff. So it is in the BNF. So we go to the while loop BNF right here, and it goes down a little bit right there. Okay, so zoom in just a little bit. Okay. What is the first bullet point saying? The first bullet point, which is this one here. It's in BNF, okay, because the colon equal thing is only useful when we are specifying BNF. So how would you describe this in English? Yes. Mm, okay, so I think you get the idea, okay, but okay. So the key is what is colon equal is okay. I like the word expand, but there's one more thing that is important. Now, does it say this is the only way to expand? Can expand to. Okay, so the key word here is can expand to. So that means a statement can expand to a while statement. A statement can expand to an assignment statement. A statement can expand to a do statement. Okay, a statement can expand to a block statement. So those are the types of statements that can all be collectively be seen as a single statement. Is that okay? So that's one thing. The other thing that is also important to understand the program, the syntax that we just looked at, is a compound statement. So when you go, or a block statement, which is also known as a compound statement. So when we look at a block statement, let's take a look at the syntax here. It also says a statement can expand to a block statement. So a block statement can be seen as just a statement. Okay, and that's the whole idea. Okay, it's just like a zip file. A zip file expands to multiple files, but guess what? When you're looking at just the zip file itself, it is one single file, even though logically within it, there are multiple files inside. Is that okay? So how does this all relate? Okay, so this is where I'm going to give you a compiler's view on things. Okay, so let me switch to the right tab. There we go. And I need to open up my tablet too. So give me a second to get that working. All right. So I got this. And I want to display both the original text and the tablet at the same time. So I have to do some little massaging here to get it to work. Give me a little bit more time to fine tune the size of the window. So there we go. Put this one here and then stash this one over here. And then expand this one as much as I can. just so that you can view the entire area of the tablet. There we go. Okay, this is it. So what I'm going to do is to write the code out. Okay, so we have, oh, why is it not working? Is it off? Yep, press power button to wake up. There we go. Now it's up. Okay, so we have s equals 0, semicolon. Okay, so we're going to do this step by step. The compiler starts with the first letter, okay, the first character, which is S in this case. So let me use a mouse pointer to point to the focus of the compiler. The compiler is looking at this right now. Um, does it indicate that we are beginning a conditional statement? What would a conditional statement start with? What word do we use to start a conditional statement? The word if. Are we looking at the word if? No. Can this be the starting point of a do loop? What word do we use to start a do loop? The word do itself, right? Are we starting a while loop? Nope. Are we starting a block statement? No, because a block statement starts with a brace, okay? And that's not a brace. It's not an open brace. So it doesn't match any one of those other statements. So the only thing left is an assignment statement. So with an assignment statement, now that's not actually the case. It can be any expression, but I'm just going to say it's an assignment statement for the simplicity of this class. So with an assignment statement, what components do we expect with an assignment statement? Okay, an assignment statement has which three main components? Has a left-hand side to specify what variable we are updating, followed by a equal symbol, followed by a right-hand side, and because it's a statement, we are also expecting a semicolon. Is that okay? That to turn it into a statement, because otherwise you just have an assignment operation, which is not a statement. So now the compiler says, okay, I'm expecting a left-hand side, which is a variable, an equal symbol, and then the right-hand side, which can be any expression, and then a semicolon. So now the compiler goes like, okay, cool. I think the variable name s can be seen as a left-hand side. Cool. The equal symbol is a terminal, and we are matching exactly that. The expression of 0 is simple, but nonetheless, it is still an expression. It can serve as the right-hand side. And the semicolon is just a semicolon. So now we have a match. The compiler says, cool, we got a statement. So the whole thing becomes a statement. So what is after s equals to 0? X equals to 0. Same deal, okay? So to the compiler, x equals 0 is after s equals to 0, and it goes through the same process again. It's like, what kind of statement are we looking at? Is it a do statement? Nope, because do statements always start with the word do. Is it a while statement? Nope, a while statement always starts with the word while. Is it a conditional statement? No, because a conditional statement always starts with the word if. Is it a block statement? Nope, because a block statement always starts with an open brace. Okay, if it's none of the above, it has to be an assignment statement. So now it goes like, okay, well, if it is an assignment statement, then I'm expecting the following again. So I'm expecting to the compiler, okay, our attention is right here. So the compiler now says, okay, same thing. I'm expecting a left-hand side, a equal to a right-hand side, and a semicolon, and then it will do the matching again. Okay, all right, cool. Everything matches up. So now this is now seen as an assignment statement, which is a statement again. Is that okay? What is the next thing that it's going to see? While blah, 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 blah. Okay, so we'll say the next one is, okay, the next one is going to be complicated. So I'm going to continue over here. So it starts with while x is less than 3. Okay, well, I'm just going to start with this. So the compiler goes again. It's like, okay, what kind of a statement do we have? Well, is it a do statement? No, do statement starts with do. Is it a conditional statement? No, conditional statement starts with the if. Is it is it a while statement? Oh yeah, only a while statement would start with the word while. So right away, the compiler says, I'm expecting the following. The compiler says in expectation, saying, I'm expecting the while word, which is what will be found. I'm expecting open paren. I'm expecting a condition. I'm expecting a single statement here. That's what the compiler is expecting. Is that okay? Now, when did we talk about this? The B and F of a while loop. Okay? And that's why the concept of B and F is so important, because this is how we can understand what the compiler is expecting as it goes through the text of your code. Okay? So now that the while token is, or the while terminal is matched, okay, it's all good. Open parent is matched, fine. Okay. This whole thing, I'm not going to talk about why it can be understood as a condition, but it does. So this one is the condition, and we have a close parenthesis. So everything is working out fine. Now the compiler says, okay, now give me a statement. Okay. What is right after this? Well, right after this, we see open brace. Okay, this open brace here is the same open brace on line 3 right here. Now remember, empty space does not matter to the compiler. Line feed, or where you break into multiple lines, does not matter to the compiler. The comments are basically ignored. Anything after the slash slash is completely ignored by the compiler. So as far as the compiler is concerned, now it sees the open brace. So now it's asking, I'm seeing an open brace in your program, but I'm expecting a statement. How do I get this to work? So now it has to figure out, what kind of a statement is this? Do you guys want me to bore you again? I can do that. Okay, let's do it. I'll bore you again. So the compiler says, can it be a do statement? No, because a do statement does not start with an open brace. A do statement starts with the word do. Okay, that's not do. Is it a while statement? Nope, it's not while. Is it a conditional statement? Nope, it's not a. It's not if, right? So now it moves on to, can it be a block statement? So when you look up the BNF of a block statement, it says it has to start with a brace, an open brace. So now the compiler says, oh, okay, so I'm expecting a block statement. So what is in a block statement? Well, a block statement needs to start with an open brace, and it can have optional statements inside of it. Is that okay? So now the compiler goes like, well, is it empty? So now that we are done with this brace here, the compiler moves on and go like, okay, what's inside it? Y equals to 0 is the next item. So now it goes to the Y. It goes like, okay, is this an empty block statement? In other words, is the open brace followed immediately by a closed brace? Nope. Okay, so it's not an empty block statement. If it's not an empty block statement, that means it has to contain at least one statement. So now it knows, okay, I'm expecting to see one statement. But what kind of a statement am I looking at here? It goes through the whole boring process again. I see the word Y, the letter Y, and I'm trying to match it with do. Nope, doesn't match. While doesn't match. If does not match. Open brace does not match. Okay, the only thing that it can possibly be is a assignment statement. Okay, so once it knows that it's expecting an assignment statement, then it goes through the whole process again and say, okay, there's a left hand side equal to right hand side, and then the semicolon. Okay, and everything matches up. Okay, like that. And this is just a statement, because an assignment statement is a statement. Okay, and now the magic begins. Okay, the fun part starts here. You guys, think that, okay, we have already talked about all this. Now the next word it encounters is while. Okay, so I'm going to move the cursor over here, which is corresponding to the word while on line 5. Okay, and so we have a statement here. um, when you look at the BNF of a block statement, it can be a single statement, but it can also be statements followed by a statement. So in this case, we have multiple statements because it is not a closed brace, which means this is not a block with only one statement. This is a block with multiple statements, which means the compiler says, okay, we know that I'm looking at the beginning of another statement. But what kind of a statement is it? It goes through that whole process again. Is it a do statement? No. Is it a block statement? No. Is it a conditional statement? No. Is it a while statement? Yes, we got a match. So now the compiler goes like, okay, this is the beginning of a while statement. So now it sets up its expectations again. While, open paren, condition, close paren, and a single statement here. Okay. So that's how the compiler works, which means in this case, we have the statement, the while statement that starts on line 5, that ends on line 8, is just seen as one statement from the perspective of the outer loop, which is starting on line 3. Okay, I just want to make sure that concept is understood. Are we doing okay so far with that concept? It is about the containment of one kind of statement inside another statement. Okay. Now, technically speaking, the while loop starting on line 5, ending on line 8, is a statement inside a block statement. The block statement that I'm talking about starts on line 3, ends on line 10, because that's the outer block statement. Okay. And that block statement is the one single statement that is to be repeated from the perspective of the outer loop, which is corresponding to while x is less than 3 on line 3. So those are the levels of embedding or nesting in this particular case. Yes, go ahead. Line 9. So line 9 is the third statement of the block statement that is the statement of the outer while loop. Okay, let me present this in just a different way. Okay, so I'm gonna change to a different view on the tablet. Okay, so s equals to 0 is one statement. X equals to 0 is one statement, and then we have while x is less than 3. That is one gigantic statement. Okay, inside this statement is a block statement. So I'm putting the curly brace, in its own block here, because that technically is its own containment. It is its own statement. And then inside that block, we now have y equals to 0 as a statement. And then we have the whole thing of while y is less than 2 as another big statement. Okay. And then x gets x plus 1 is another statement here. So inside the inner while, okay, inside this inner while here, we have a single block statement. That's the limitation of the syntax, is you can only specify one statement as quote unquote the body of a loop. But you are allowed to use a block statement for that one single statement. But you can fit as many statements as you want into a block statement. And that's what the block statements are used for in C++. Because now when you look into this space here, the innermost rectangle, this is where we put x gets y gets y plus 1. That's one statement. And then s is a little bit more complex, but it's not super duper complex like that. So this picture is it shows you the nesting of the statements. Which statement contains which other statement. Now, if you want me, I can also label the type of the statements. Yes, go ahead. Yeah, it's a zip file. Because there are certain places where you can only have one file. And they go like, one file, but I got a bazillion files that I want to put here. But the restriction of the file system is, let's say Windows, but no, you can only have one file here. Then you go like, okay, fine, I have a little way to get around that problem, because I know there's a zip program. All the files that I want to include here, I will zip it into one single zip file and then stash the zip file over there. That's the whole purpose of a block statement. So now, if I look at the types of statements, these are assignment statements. So I'm just mapping all of these to these are all assignment statements. This one here, and no, they are not. These two are while statements. And then we have this one and this one here as block statements. So those are the types of statements. So in the entire pseudocode here, we only have 3 different types of statements. Now, in terms of the number of statements, every rectangle is a statement. So we have a lot of statements. But then the containment of the blocks is also important. So when people ask how many statements is in this pseudocode, or not pseudocode, in this C code, you kind of have to ask, are we counting all the rectangles, or are we counting rectangles within a specific rectangle? Okay, because that is an important question to ask. So are we getting a better understanding of the structure of the code? Yes.
So the while statement is holding the majority of the other statements.
The outer while statement is holding basically everything other than s equals to 0 and x equal to 0. They are basically all a part of the outer while statement, which starts on line 3. So are we doing okay so far with this picture? And also how it relates to the process of how things are parsed. Okay, the process that I described a little bit earlier, this part here, is called parsing. Parsing, parsing. Okay, which is basically describing mechanically how does a compiler look at the text that you specify and how it can understand how everything relates. What is the structure. But after the parsing, I only finished like a really small portion of the parsing. But after the parsing, this is how the compiler understand about the structure of the code that is specified by the text. Is that okay? All right. And then, okay, let me switch back to my browser here. So, and then after that, now we have this picture. Okay. Uh, Opposite. There we go. I'm gonna zoom all the way out, just so that I can, display that on the side, hopefully. Okay. Sort of. Okay. So you can still see basically the whole thing. So this is the meaning of the structure. In other words, let me see what I can do here. Okay, I can do this. I really like this tool. Just take a snapshot of this and stash it on the side. Uh, Now I have to rearrange things a little bit better. There we go. And then switch back to here. There we go. But I did not make the other one always on top. Always on top. There we go. Okay. So now we have all 3 pictures. This is the text. Okay. This is what you actually type in an editor, like Notepad. Okay. That's how you specify the code. This is the structural view of the same code. What is contained within what else? This one over here is the flowchart. It tells you when you execute a code, how do we execute a code? So are we understanding the whole thing? Are we relating the 3 pictures? Because they are related. How you specify the text, how the text is understood by the compiler from the structural perspective, and what does it mean to the compiler? In other words, when we try to follow the algorithm, what do we do when we follow the algorithm? That's the flowchart. Are we getting all the pieces down? Okay, excellent. All right. So I'm gonna take a quick row here. Okay, so we're gonna suspend the topic for the time being. And I'll go ahead and take roll. I don't have one already made, so I'm just going to make one really quick here. All right, so this is going to be a quiz, or in the form of a quiz. It's not an actual quiz. And the quiz name is Roll on 2025-0212. And the group is just Roll. And I need to get rid of this. Add item. You cannot see it yet. I still have to do a little bit more to make it visible to you. All right. So I am going to specify required access code, and we'll just say block is the access code. And I'll give you guys until 10:30. It wants me to specify the date, obviously, but there's a reason why I do this. Because if I were to specify the date first, it will automatically put in the end of the day as the time, and that means I have to go change it again. All right, so if you refresh your browser, you should be able to get into the quiz, and the access code is just block, BLOCK, all lowercase. And remember to click the submit button once you're in the quiz, because otherwise I still cannot see that you attempted the quiz. You should get a score of 0 out of 0 after the submit. That's normal. Okay, that's exactly what you should be seeing once you're done with this activity. And for the next 3 minutes or so, I'm just gonna kind of broaden up the discussion a little bit here. And I want to see if you guys have any questions about how. Yeah, go ahead.
Question about the trace
Uh
on
huh.
the
Okay.
nested statement.
Uh huh. So let's go back to. Okay, where? Oh, okay. The trace is this trace here.
Yeah, so it's for the first 7 lines, so 1 through 7 is first one.
Mm-hmm.
Why is S still 0 if um if S is Y plus X?
You're correct. Okay, I goofed up here because this one should be a one because of that
Okay,
one
that's
here.
how.
Okay, I goofed. Okay, so that means the rest of the values also need to be changed. They're all one more than what they should be. Yep. Good. Very good. Good catch. Okay, so let me go fix that. Uh, yep. So I do make mistakes too. So we are talking about this one. This should be a one. Then everything else should be one more than what they are recorded. So this would be four. This will make it 7. This would be 10, 14. Okay. And now we can update. Get rid of that. Commit changes. There we go. All right. So we still have 2 minutes left, okay, which is good. If you are finding this material really challenging, and you want to know how to approach all this stuff, you're more than welcome to come talk to me, okay, before class or after class, or we can schedule even a different time, because um, this is how computer science classes will be. Okay, this is the track of computer science. This is the first class of the entire track. And at ARC, we only cover the lower division classes. Once you transfer, then you get to upper division classes. Do you think upper division classes will be any easier than the lower division classes? The answer is no. Okay, so that means trying to learn how to learn as early as possible. It will give you the most return. Okay, it's kind of like investing money. Okay, investing money earlier will give you more return in the end. So if you want to get into those topics, I cannot spend enough time in the class to talk about study skills and stuff like that. But if you come to my office individually, I can help you with those topics. You can also take a class in red, reading across the discipline. those are really helpful because they're just helpful across all the different classes that you take. ESL classes can also be very helpful for certain people. Okay, for if you want to improve your mastery of the language itself, ESL classes are helpful. But for this class, it is specifically complex, abstract, and and also we cover a lot of material. Okay, so if you want to learn how to learn better in a class like this, come talk to me. Okay, so that's the end of today's lecture. Okay, I will see you guys next Wednesday, not Monday, because Monday is a holiday. So don't forget.
I just got a quick question. So
Yes.
your hours in person